Now we will prove that the integral over the whole values of x of the probability density function of the gamma distribution with the two parameters, that is the lambda and a, is equals to 1. So let's start the proof. Firstly, we will take this constant term outside the integral because this term does not contain x. Next, we have to form here only one variable because we want to use here the formula of the gamma function, which is equals to this one, in which e raised to power minus of, here we have only one variable. That's why we will substitute this ax is equals to y. From here we can calculate the value for x is equals to y divided by a. Now we will differentiate this both sides with respect to y. So we have this term. Next, from here we take the value of dx is equals to dy divided by a. So we will use now these three equations in this whole integral. That is, at the place of ax we will write only y because of this equation, and at the place of x we will write y divided by a because of this equation, and at the place of dx we write here dy divided by a because of this equation. Moreover, we also have to change these limits according to our new variable y. So you can see that when value of our x is equals to 0, value of our y will be 0 multiplied by a, that is again 0. That's why we write here 0. Next, when value of our x is equals to infinity, then value of our y is equals to infinity multiplied by a, that is again infinity. That's why we write here only infinity. Next, since bases are same, so we can add the powers, that is lambda minus 1 plus 1 is equals to lambda, that is 1 divided by a raised to power lambda. We take this term outside the integral because it does not contain y, so that's why it will be considered as a constant term. Next, we know the definition of the gamma function is equals to this. On matching this whole term with this term, we can clearly see that just at the place of x we are using here the variable y. So that means also, since its value is equals to gamma m, because here we have m, so now its value is equals to gamma of the lambda because here we have lambda at the place of m. So that's why we write here gamma of the lambda. Now this term will be cancelled out by this term and we get only 1 as our answer. That is, we have proved that the integral of PDF of the gamma distribution is equals to 1.